Hey there, space voyagers! Welcome back to Singularity, your favorite channel where jet fighters, rockets, and the universe crash together into one cosmic roller coaster. Today, we're diving headfirst into the deepest, darkest, most terrifying vacuum cleaners of the cosmos, black holes. And trust me, once you're in, well, not even light can show you the way out. So buckle up, because today's ride goes beyond the event horizon. And yes, you're allowed to scream. First things first, what is a black hole? Think of it as nature's way of saying, oops, I overdid gravity again. A black hole forms when a massive star, at least 20 to 25 times the mass of our sun, ends its life in a spectacular supernova and leaves behind a core so heavy that it collapses under its own weight. It squeezes into such a tiny space that its gravitational pull becomes too strong even for light to escape. That boundary beyond which no light returns is called the event horizon. It's basically the ultimate do not cross line in the universe. Try crossing it, and even GPS gives up on you. And here's something wild. The more massive the black hole, the bigger its event horizon. That's right, black holes come in sizes ranging from dead star leftovers to this thing eats galaxies for breakfast. Let's start small. Stellar mass black holes. These guys are the cosmic toddlers of the black hole family. They form when stars collapse, usually leaving behind a mass between 3 and 50 times the mass of our sun. Their event horizons? Tiny, just a few kilometers across, about the size of a small town, but a small town that could stretch and spaghettify you into atomic noodles in milliseconds. Now, these black holes come in two moods, active and quiescent. Active ones are like toddlers with a sugar rush. They're constantly feeding on nearby gas and stars, emitting X-rays like they're trying to win a space disco contest. Quiescent ones? More like sleepy cats. They're still deadly, just not currently munching on anything. And in true minimalist fashion, black holes follow the no-hair theorem. That's not a comment on their fashion sense. Though let's face it, baldness suits them. It means that, once formed, a black hole only retains three features: mass, spin, and electric charge. That's it. You could throw a piano, your annoying roommate, or a quantum particle into it. Black hole doesn't care. It remembers none of it. No hair, no history, no drama. So how big do these stellar mass ones get in size? Say a 10 solar mass black hole has a radius of about 30 kilometers. That's it. 10 suns squashed into a sphere smaller than Manhattan. Imagine trying to find parking inside that. Speaking of finding things, where's the closest black hole to Earth? Well, as of now, the title goes to Gaia BH1, discovered in 2023. It's about 1,600 light-years away in the constellation Ophiuchus. Its mass? Roughly 10 times the mass of our sun. But here's the kicker. It's completely dark. No X-rays, no glow, nothing. It's the cosmic equivalent of a ninja. And it proves something important. There may be black holes lurking even closer to us, silently waiting in the shadows. Comforting thought, huh? Now let's scale up. Let's talk about intermediate mass black holes, aka the awkward middle children of the black hole family. These guys range from a few hundred to a few 100,000 solar masses. Their event horizons span from tens to hundreds of kilometers. They're rare, elusive, and often found doing weird stuff like chilling at the centers of dwarf galaxies. Scientists have been scratching their heads over these things for years. How do they form? Why don't we see more? Is it okay to call them moderate? Nobody knows for sure. It's like trying to find the introvert at a wild party. They're there, just not looking for attention. But if intermediate ones are awkward, supermassive black holes are the rock stars. We're talking masses from a few million to tens of billions of times the mass of the sun. These monsters sit at the centers of almost every major galaxy, including our own Milky Way. Their event horizons are huge. The black hole at the center of our galaxy, Sagittarius A*, weighs in at about 4 million solar masses and has an event horizon of about 24 million kilometers. That's bigger than Mercury's orbit. And yet, it's been mostly quiet lately. Probably just digesting its last meal for the next million years. But some supermassive black holes are way more active, and when they are, things get wild. Ever heard of a radio galaxy? These galaxies shoot out giant jets of radio waves, thanks to intense magnetic fields and spinning black holes at their cores. Imagine a black hole so powerful that instead of just sitting there sulking in darkness, it whips up plasma jets traveling at near the speed of light. Jets so long they can stretch across millions of light years. It's like a laser pointer on steroids. Great if you're aiming for alien cats. Then we've got blazars, the cosmic sniper rifles of the black hole world. These are active galactic nuclei where one of the jets is aimed directly at Earth, which means we get a front row seat to some of the brightest and most energetic phenomena in the universe. Blazars say, "Hey Earth, here's a beam of relativistic death traveling across time and space at nearly light speed." Friendly, right? Next up, Seyfert Galaxies. These are black holes that are active but not overly dramatic, kind of like someone who drinks just one espresso instead of 3. They're moderately bright, emit strong ultraviolet radiation, and their central regions outshine the entire rest of the galaxy. And now, quasars. Oh boy. If supermassive black holes are rock stars, quasars are the sold-out pyrotechnics-loaded world tour. These are the most luminous and energetic objects in the known universe. Powered by black holes feeding like there's no tomorrow, quasars can outshine entire galaxies. Their luminosity can be 1,000 times that of the Milky Way. How big is their event horizon? Let's take TON 618, located over 10 billion light-years away, one of the biggest known quasars. It contains a supermassive black hole weighing in at about 66 billion solar masses. That's right, billion with a B. Its event horizon is roughly the size of the solar system. The whole thing, Sun to Pluto, and its jets? Spewing matter at nearly the speed of light across millions of light-years. Quasars can gobble up mass at incredible rates, some estimated to consume hundreds of solar masses per year, or even up to 10 suns worth of matter per second during peak feeding frenzies. It's a cosmic buffet, and the black hole is very hungry. So far, we've discovered over 750,000 quasars, and counting. They're scattered across the observable universe, mostly found in the very distant past, meaning the light we see now left them billions of years ago. In a way, looking at a quasar is like opening a time capsule from when the universe was just a baby with galaxy acne. Now, just when you thought it couldn't get any crazier, let's talk about the real giants, ultramassive black holes. These are theoretical or extremely rare black holes that exceed 100 billion solar masses. Yes, they exist. Maybe. Possibly. There's even speculation that some galaxy clusters might host these ultra-hungry beasts. They're mostly quiet, which is kind of scary. It's like knowing there's a nuclear bomb buried under your lawn, and it's just chilling. No sound, no light, just waiting. So, to wrap things up, black holes are terrifying, mysterious, and amazing. From stellar mass little beasts to supermassive and ultra-bloated gravity monsters that twist space, time, and your brain. Some spin like cosmic blenders, some shoot laser beams across the universe, and others just lurk silently nearby, possibly watching you. Yep, sleep tight tonight. And hey, if you love this journey through the dark side of the universe, make sure to like this video and subscribe to Singularity. We've got plenty more where this came from. Jets, rockets, neutron stars, alien bacon farms, you name it. Drop a comment below and tell us, what should we explore next? Wormholes? Dark energy? Could your ex be a black hole in disguise? Let us know. Thanks for watching. Until next time, keep your feet on the ground and your mind in the stars.